Now let us see the next property, Laplace transform of integrals. Laplace transform of integrals. So what is the statement of this property? What is the statement of this property? If L of f of t equal to f bar of s, then Laplace transform of integral 0 to t f of t dt, integral 0 to t f of t dt is equal to f bar of s by s. Here f bar of s is nothing but L of f of t. Right now, see here Laplace transform of the integral 0 to t f of t dt is equal to f bar of s by s. Right now, if you have a single integral, then we are writing f bar of s by s. See here we have to know some note points. See, listen to me. The first note point is what that Laplace transform of a single integral 0 to t f of t dt is equal to what is that f bar of s by s. Here f bar of s is nothing but L of f of t, right? Now what is the Laplace transform of the double integral 0 to t f of t dt is equal to what happen, f bar of s by s square. So if you have the double integral in the denominator, we can write s square, right? So f bar of s by s square. So similarly, if you have the triple integral, Laplace transform of triple integral 0 to t integral 0 to t f of t dt. So this is equal to what happen, what will write f bar of s by, what will write in the denominator if you have the triple integral, s cubed, right? What that, if you have the single integral in the denominator, you can write s. If you have the double integral, you can write s square. If you have the triple integral, you can write s cubed. Similarly, we can do Laplace transform of what is that, fourth integral or fifth integrals, right now, like that you can write. So and so on, you can write it, and so on, right? Now we have to see the problems on the Laplace transform of integrals. We have to see the problems of what that Laplace transform of integrals. So what are the problems of Laplace transform of integrals? See that the problems on Laplace transform of integrals. So what are the problems on Laplace transform of integrals? Here and so on. So problems, we have to discuss the problems on Laplace transform of integrals. So what is the first problem? See the first problem, evaluate integral Laplace transform of integral 0 to t e power minus t cos t dt, e power minus t cos t dt. So we have to evaluate Laplace transform of integral 0 to t e power minus t cos t dt, right now. So right, So how can you evaluate the value of the Laplace transform of integral 0 to t e power minus t cos t dt? So see, how can you evaluate this one? First we have to observe the given data. What is the given data here? See that, what do you want? We want Laplace transform of integral 0 to t e power minus t into cos t dt. What is the form of this? This is of the form L of integral 0 to t f of t dt, integral 0 to t f of t dt, where f of t is equal to, what is f of t here? E power minus t cos t, right now. So what do you want? We have to find L of f of t, right? To find L of f of t value, first I can find L of cos t value, then I can apply the first shifting property, then you can get Laplace transform of f of t value, you can get it, right? So see here, first I can find L of cos t value. What is L of cos a t formula? L of cos a t formula is s by s square plus a square. No? So by using that formula, how can you write L of cos t? See that, first I can write now L of cos t I can write. So what is L of cos t? Here L of cos t value is s by s square plus a square, we have to write a value is 1, I can write 1 square. So this is equal to s by s square plus 1, right? Now I can find L of f of t. So this is equal to L of, what is f of t here? E power minus t cos t. So this is equal to, what is the form? This is of the form L of e power minus at f of t form. So first you can write L of cos t value, then you can change s to s plus 1 by using the first shifting property. What is that? We can write L of cos t value, then we can change s to s plus 1. We can change s to s plus 1, since by using what is that? By using first shifting theorem or first shifting property, since by using first shifting theorem or first shifting property, right? What is L of cos t value here? Here L of cos t value is s by s square plus 1. Here you can change s to s plus 1. So then what happen? S plus 1 by s plus 1 whole square plus 1. So this is equal to s plus 1 by, expand this one by using a plus b whole square formula. What happened? S square plus 2s plus 1, you can get plus 1 is a plus 2, right? So I can take this one as, what is L of f of t value? S plus 1 by s square plus 2s plus 1 plus 2. So this is, I can take this one as f bar of s. Okay, now what is that? I can use the Laplace transform of integral formula right now. What is that? See that? Now by using Laplace transform of integrals, we have what is that? Therefore by using Laplace transform of integrals, Laplace transform of integrals, we have what is that? L of integral 0 to t f of t dt is equal to what is that? F bar of s by s. Now substitute all f of t and f bar of s value. Therefore what happen? L of integral 0 to t, what is f of t here? E power minus t cos t dt is equal to what is that? F bar of s means s plus 1 by what is that? S square plus 2s plus 2. In the denominator what is there? S is there. So what happen here? Into s. So this is the solution of the first problem, right now. So this is the solution of the first problem, right? Okay. Now we have to go to the second problem. We have to go to the second problem. Now the second problem is find the Laplace transform of integral 0 to t t into sin t dt into dt. So this is we have to find. What is that? Find the Laplace transform of triple integral 0 to t t sin t dt, right? What is that? We have to find the solution of what is that? Laplace transform of triple integral 0 to t t sin t dt. So this is in the form of Laplace transform of what is that? Triple integral t f of t dt form. Here where f of t is equal to, here what is that? F of t is equal to, this is of the form L of triple integral 0 to t f of t dt, right? Where f of t is equal to what is that? T into sin t. Now we have to find L of f of t value. So before finding L of f of t, first I can find L of sin t value, then I can find L of f of t value I can find, right? So first what is that? First we have to find the L of sin t value, then we can find L of f of t value. So what is L of sin a t value? L of sin a t value is a by s square plus a square, na? So here what is a value? A value is 1. So we can write 1 by s square plus 1, right? Okay, see that? What that? First I can write the L of sin t value. Laplace transform of sin t value is what is that? A value is 1 here, 1 by s square plus a square means 1 square, so it is nothing but 1 by s square plus 1. Now I can find L of f of t value. L of f of t. L of f of t. This is equal to L of, what is f of t here? T sin t. Right? So this is equal to, how can you find this value? This is in the form of L of t power n into f of t. So L of t power n into f of t means what is that? Multiplication by t power n. Right? What is that? See here. What is the formula you have to use here? L of t power n into f of t form. L of t power n into f of t form means multiplication by t power n property. So what is the value? Minus 1 whole power n into d power n by ds power n of f bar of s. Of f bar of s, or you can write f bar of s is nothing but L of f of t. L of f of t. F bar of s or what is that? L of f of t. Both are same, right? So here I can use the multiplication by t power n property. What is n value here? N value is 1. What is the n value here? N value is 1 here. Then I can write this one as minus 1 whole power, what is that n value? 1 into d power 1 by ds power 1 means d by ds of what is that? F bar of s. F bar of s is nothing but L of f of t. L of f of t means L of sin t here. Here f of t means sin t here. So this is equal to what happened? Minus d by ds of, what is L of sin t value? L of sin t value is 1 by s square plus 1. 1 by s square plus 1. Now we have to differentiate 1 by s square plus 1 with respect to s. So how can you differentiate? This is in the form of what is that? Derivative of what is the form? Derivative of 1 by x with respect to x. What is the derivative of 1 by x with respect to x? Minus 1 by x square. So by using this formula, what is the derivative of 1 by s square plus 1? See that? Minus, this is in the form of 1 by x. 1 by x derivative is minus 1 by s square plus 1, s square plus 1 whole square. But it is not only s, so that's why again we have to differentiate the denominator value. Means the denominator value means here s square, what the denominator value means? S square plus 1. We have to differentiate the denominator value with respect to what is that? S. So this is equal to what happened here? Minus is plus 1 by s square plus 1 whole square into what is the derivative of s square plus 1? 2s. So this is equal to what happened? 2s by s square plus 1, s square plus 1 whole square. Right? This is L of f of t. I am taking this one as f bar of s say. Okay, now what do you want? Laplace transform of triple integral means I can use the Laplace transform of integrals formula. What is that? By using Laplace transform of integrals. By using Laplace transform of integrals, we have what is that? L of Laplace transform of integral 0 to t f of t dt is equal to what is that? F bar of s by f bar of s by. If you have the single integration, you can write s. If you have the double integration, you can write s square. If you have the triple integration, you can write what is that? S power 3. So substitute all the f of t value and f bar of s value. Then what happens? Therefore, L of integral 0 to t integral 0 to t, what is f of t here? T into sin t, t into sin t into dt, dt, dt. So this is equal to f bar of s. What is f bar of s value here? 2s by what is there? S square plus 1 whole square. Right, already what is there in the denominator here? In the denominator s cubed is there. I can write s cubed here. Then what happened? 1 s term is cancelled here. How many terms are there? 2 terms are there. So this is equal to what happened? 2 by s square into s square plus 1 whole square, s square plus 1 whole square. So this is the second problem of the Laplace transform of integrals. Now moving to the third problem. So you have to remember the statements of all the properties, then the problems are very easy, right? Otherwise problems are very difficult. So we have to identify which property is suitable for doing the problem. That is main thing. Okay, if you identify, then problems are very easy, right? Okay, now see the third problem in the Laplace transform of derivatives. The third problem is find the Laplace transform of Laplace transform of t into integral 0 to t e power minus t into sin t by t into dt, right? So this is the problem. Okay, what do you want? We have to find the, what is that? Laplace transform of, means L of t into integral 0 to t e power minus t sin t by t into dt, right now. So how to find? See, this is in the form of L of t power n, L of t power n into f of t form, L of t power n into f of t form, right now. What is that? This is of the form L of t power n into f of t form. Here what is f of t? Integral 0 to t e power minus t sin t by t into dt. What we have to do? First we have to find this value. What is that? First we have to find this value by using the Laplace transform of integrals. Then we can apply the multiplication by t power n property, right? So what is that? First we have to find the Laplace transform of integrals. Okay, first we have to use the Laplace transform of integrals property to find the Laplace transform of integral 0 to t e power minus t sin t by t into dt value, and then we can apply the multiplication by t power n property, right? So to use the Laplace transform of integral property, first we have to find Laplace transform of e power minus t sin t by t value. So for that, first I can find sin t value, next I can find Laplace transform of sin t by t value, and then I can find Laplace transform of e power minus t by t value I can find. Right now what is that? One by one we can do it. See here, in the first step we have to find L of sin t value. L of sin t. What is L of sin t? L of sin t value is, what is that? A by, A means here 1, A value is 1 by s square plus 1 square, 1 square means 1, right? Now what is that? I can find L of sin t by t, L of sin t by t by using the division by t property. Okay, so what is the division by t property formula? Integral s to infinity integral s to infinity f bar of s. F bar of s is nothing but L of f of t. Here what is f of t in this case? In this case f of t is what is that? Sin t. So means f bar of s means L of sin t. Here you can write f bar of s means you can write L of sin t. L of sin t into ds. So what is the property I have used here? By using what is that? By using Laplace transform of by using division by t property. By using division by t property. By using division by t property. Right, now see this is equal to, so what is L of sin t value? So see here, this is equal to integral s to infinity. What is L of sin t value? 1 by s square plus 1 into ds, right? So this equal to, so what is the integration of 1 by s square plus 1? This is in the form of what is that? Integral. This is in the form of integral 1 by x square plus 1 into dx. What is the formula for integral 1 by x square plus 1 into dx? Tan inverse x. Here in the place of x what is there? S is there. So you can write tan inverse s. What are the limits here? The limits are s to infinity. Now substitute the upper limit. If you substitute the upper limit, what happen? Substitute the upper limit in the place of s. Tan inverse of infinity minus, substitute the lower limit in the place of s. What is the lower limit here? S. Substitute s in the place of s. What is that? We can get tan inverse s. But what is tan inverse of infinity value? So tan inverse of infinity value is pi by 2 minus tan inverse s. Pi by 2 minus tan inverse s, right? So this is equal to, what is pi by 2 minus tan inverse s? Pi by 2 minus tan inverse s is nothing but cot inverse of s, right? This is the value of L of sin t by t value. Now I can find L of e power minus t into sin t by t value. I can find Laplace transform of e power minus t into sin t by t value. How can you find this one? By using the first shifting property, because it is in the form of L of e power minus at into f of t form, right now. So see here, first we can write the value of L of sin t by t. Then we can change s to s plus 1. Change s to s plus 1. So what is the property I have used here? By using first shifting theorem. So this is equal to, what is L of sin t by t value? Cot inverse s. Here you can change s to s plus 1. So this is equal to, what happened? Cot inverse of s plus 1. Cot inverse of s plus 1, right? So this is completed. What is that? Laplace transform of e power minus t into sin t by t value is completed. Now what do you want? We need, what is the value we need? Laplace transform of integral 0 to t. What is the value we need? We require, what is that? Laplace transform of integral 0 to t e power minus t into sin t by t into dt value we need. So how can you find this value? We can find this value by using the Laplace transform of what is that integrals formula, by using the Laplace transform of integrals property. What is the Laplace transform of integrals property? We can find what is that integral, what is that Laplace transform of integral 0 to t f of t dt f bar of s by s, f bar of s by s. Right now f bar of s is nothing but L of f of t. What is f of t here? F of t is e power minus t sin t by t. What is f of t here? E power minus t sin t by t. Right now, so what is the Laplace transform of integrals formula here? F bar of s, f bar of s. Suppose if I take this one as f bar of s, because it is the value of what is that L of e power minus t into sin t by t value this is. So that's why I have taken this one as f bar of s. Then what is that Laplace transform of integrals formula? F bar of s by f bar of s by what is that s. So this is equal to what is that f bar of s value? Cot inverse of s plus 1, cot inverse of s plus 1 by s. Okay, now finally what do you want here? What is the property I have used here? Here I have used the property, what is that Laplace transform of integrals property. Okay, now finally what do you want? Finally we want Laplace transform of t into integral 0 to t e power minus t sin t by t into dt. Right, put that Laplace transform of t into integral 0 to t e power minus t sin t dt, that is we require. Right now how can you find that value? By using the multiplication by t power n property. Right, finally what do you want? Finally we have to find Laplace transform of t into integral 0 to t e power minus t sin t by t into dt. So by using multiplication by t power n property, it can be written as minus 1. What is n value here? Here t power is 1, so minus 1 whole power 1 into d power 1 by ds power 1 means d by ds of f bar of s. In this case f bar of s means what is that? L of f of t. What is L of f of t here? What is f of t here? This is f of t. This is f of t means I can write L of integral 0 to t e power minus t sin t by t into dt. Right, so this is equal to what is that here? Minus 1 whole power 1 means minus d by ds of, so what is L of integral 0 to t e power minus t sin t by t into dt value? Cot inverse of s plus 1, cot inverse of s plus 1 by s, cot inverse of s plus 1 by s. Right, so now we have to differentiate. How can you differentiate? We have s in the numerator and we have s in the denominator, so we can differentiate that by using the derivative of u by v formula. What is the derivative of u by v formula? Derivative of u by v formula we have to use. What is the derivative of u by v formula? V into u dash minus u into v dash by what is that? V square. So by using this formula we can differentiate that. So minus, okay, see that what is u here? U is cot inverse of s plus 1, v is s, so v into v means s into what is the derivative of cot inverse cot inverse s plus 1 here. So derivative of cot inverse x. So what is that? See, here I can write what is that? Derivative of cot inverse x with respect to x is minus 1 by x square plus 1. So this is the derivative of cot inverse x formula. Right, now what is the value of cot inverse of s plus 1? Minus 1 by x. X means here s plus 1 whole square. S plus 1 whole square plus 1. Right, so what is that? V into derivative of u is completed, minus u into, u means cot inverse of s plus 1 into derivative of s with respect to s is 1 by v square. V square means s square. Right now, so simplify this one. What happened? So that is equal to if you simplify minus take inside, what happened here? The first term minus minus is plus here plus, so minus take inside, what happened? S by expand the denominator by using a plus b whole square formula, s square plus 2s plus 1, already 1 is there, what happened? Plus 2 minus cot inverse of s plus, okay, sorry, minus, if you take the minus inside, what happened? This minus becomes a plus cot inverse of s plus 1 by s square. Right now, if you take this s square plus 2s plus 2 as a LCM, then what happen? S plus s square plus 2s plus 2 into cot inverse of s plus 1 by what is there? S square into s square plus 2s plus 2 you can get. So right now, so this is the solution of the third problem. Right, so we have some more problems. If you practice them right now, you will get a good idea on Laplace transform of integrals. Laplace transform of integrals. Right now, so see, please note down that problems, then you can practice them. Right, please note down the fourth problem. See, the fourth problem is please note down this fourth problem. Evaluate Laplace transform of integral 0 to t e power t sin t by t into dt. Right, now the fifth problem is evaluate Laplace transform of evaluate L of e power minus t integral 0 to t sin t by t into dt. sin t by t into dt. So please practice these two problems, right? Okay, thank you.